All right, so this video is for your first homework when it actually comes to dealing with ionic nomenclature. So we're actually writing out the name as well as the formulas and the cation and anion. So this is ionic nomenclature practice 1. So I'm going to go through a decent amount of these. I'm not going to go through all of them, but hopefully this should kind of give you the gist. So again, you will need your periodic table for this. So I already have mine kind of up here. So we kind of need to recap those charges probably again. Okay, so we'll make sure you know your charges. So starting off here to the right side, I have a 0, and then I have -1, -2, -3, plus or minus 4, and then +3, +2, and then +1. Okay, so this first homework does not really deal with the actual transition metals, so I don't need to really worry about these yet. That'll be in the next homework. Okay, so we're going to start off just simple. So when we're doing this, we're going to write out the cation, the anion, the chemical formula, and the chemical name. So that means you need to write out the individual pieces, so like here and here, and then we're going to bring them together in the formula, and then we're going to write the name. Okay, so our first example, I gave you both the pieces, and I'm going to see that those are not balanced. So you're going to do your crisscross method. So you take the 2 to the bromine and the 1 to the magnesium. Okay, so that means you only need 1 magnesium and then 2 bromines. So there's your formula right there. Now, when it comes to naming, so remember your cation, anything in this group right here, you're not going to change its name at all. You're just simply going to write it out like you see on the periodic table. So that would be magnesium. Oop, if I can actually write. So magnesium. Okay, and then bromine is no longer considered bromine. So remember, you change your anion. If it's a monatomic, like all these are going to be, meaning it's just an element, not bonded with anything else like oxygen, making it a polyatomic, it's just going to end in IDE. So bromine becomes bromide. Okay, one thing I will say is be careful is that there is a difference between magnesium and manganese. That's probably a common mistake. So magnesium is Mg. Manganese is Mn. Okay, so be careful with those. They can get confused between the two. Now, the second example is I give you Be3N2. Okay, so that means I need to find the individuals, and then I still need to write the name. So what I'm going to do is I'm going to try the reverse crisscross method. So I would take that 3 up to the nitrogen, which means it gives it a -3 charge. And I'm going to look up at my periodic table and see, does that actually match? So if I look at N does, so N right here, nitrogen, does have a charge of -3. So that means this works, and that this is not a reduced formula. So I'm going to take that 2 from the nitrogen up to Be. Okay, and you would be able to also see on the periodic table that Be is in group 2 right here, which has a charge of +2. So again, if it's usually when you're not dealing with anything like a transition metal, you can simply just look on the periodic table and then just check for the charge there. Okay, so that means Be has a charge of +2, so there's my cation. And then nitrogen has a charge of -3, there's my anion. Now when we're going to write our name, so Be is simply beryllium, and nitrogen becomes nitride. Okay, now the next one is I gave you the name, and then I didn't give you the pieces or the formula. So what I would do is I would look up on my periodic table. Okay, chlorine is going to be in group 7A, so it's right here. It's going to have a charge of -1, and then aluminum right here. So remember, aluminum is one of the transition metals we talked about. It's going to have a charge of +3. So if you look at the top, it's always going to have a charge of +3. So that means my pieces are Al +3, and then chlorine with a -1. So it is always easiest to find your pieces first before you try to write your formula, because you have to know how to balance it first. So if I have aluminum with a charge of +3 and chlorine with a charge of -1, so you can write minus sign or a -1, doesn't matter. You can do the crisscross method, so I take the 3 to the chlorine and take the 1 to the aluminum. So that means I only need 1 aluminum and 3 chlorines. And that would be your correct answer. Okay, next one I was given Al2O3. Okay, so if you look up oxygen on the periodic table, so you can do reverse crisscross or you can just look them up. Oxygen has a charge of -2. And you can write 2 minus, -2. It does not matter. There is no correct way. Okay, I just usually write the sign first, okay, but everybody has their own way. And I look up aluminum on the periodic table as a charge of +3. So for my name, all I have to do is write aluminum, and oxygen becomes oxide. Okay, now I have Ga with a +3 and O with a -2. Okay, so gallium and oxygen. So I know that gallium and oxygen are not balanced. So I would take that 2 from the oxygen over here to the gallium, and I would take the 3 from the gallium over here to oxygen. So that means I need 2 galliums and 3 oxygens to be considered balanced. Now for my name I'm just going to write out gallium, and instead of oxygen it becomes oxide. Okay, a couple more and then we'll move on to the back side of the page. So I have calcium with a +2 charge and S with a -2 charge. Okay, so that means they're already balanced, so you can still do the crisscross method if you want to. Just make sure that you reduce. Okay, so don't write it out as Ca2S2, okay, because you don't need 2 of each to be considered balanced. All you have to do is just put them together. So CaS. Now calcium, so Ca is calcium, so we're just going to write calcium. And sulfur becomes sulfide. Okay, so hopefully you're kind of getting the gist on how to do this first part right here. So we're going to flip over to the back side because it just deals with more stuff, just a different way to ask it. Okay, so letter A says write the ions. So that means I need to write my pieces and the chemical formulas of the compound. So what it basically did is I just gave you the name and you have to write the pieces in the formula. So I would look up calcium on the periodic table. That has a charge of +2 and chlorine has a charge of -1. Okay, so again, use your periodic table, make sure you know your charges, and that just makes things so much easier for this unit. Now, I can see they're not balanced, so you can crisscross. So that means I only need 1 calcium and then 2 chlorines. And there's your answer right there. So here's my first answer is my ions, and here's my second answer is my actual formula. Now, potassium, I look potassium phosphide, so that means potassium is the letter K with a +1 charge. And phosphorus, if you come all the way back up here to your periodic table, is right here. If you look up, it has a charge of -3. So we're going to write P with a -3. So I can see that those are not balanced, so you're going to crisscross. So that becomes K3P. There's your answer right there. So there's my formula, and then here's my ions. Okay, magnesium bromide, so this would be Mg with a +2. And then bromine with a -1. So again, just get those from the periodic table. They are not balanced. So that means I need to crisscross. So that means I only need 1 magnesium, but 2 bromines to be considered balanced. Okay, one more for this one. I have aluminum nitride. So aluminum on your periodic table is Al with a +3. Nitrogen was N with a -3. Those are already balanced. So all you got to do is just put them together. So it would be AlN. And there's your answer right there. Okay, now going down here, we're just going to simply name them. That means you don't have to write out the ions. You just tell me the name. So if I look up barium, Ba, that is barium on the periodic table. So it's a cation, so I'm not going to do anything to it. So I'm just going to write barium. And then I have Cl is chlorine, so I'm not going to write barium chlorine. It becomes barium chloride. Okay, number 12, Ca is calcium. So I'm going to write out calcium. And P is phosphorus. That's no longer phosphorus. It's now phosphide. Al2S3. So I have Al, which is aluminum. And then sulfur is now going to be considered sulfide. Okay, so hopefully that kind of just gave you the gist of how to do this homework. So this one's not too complicated. We're just kind of getting started into it. So next homework, we're going to talk about using transition metals and using Roman numerals. And then the third homework, we're actually going to deal with all of those. We're going to deal with transition metals and polyatomics. So hopefully this one kind of helped out.